This video is going to start out chapter 11 if you weren't in class or if you just want to review. So I called this section 11.0. So we talk about proportion and reasoning. So once we start getting along in this chapter, we're going to deal with a lot of ratios and proportions. And so this is what a ratio is. We can write it in a bunch of different ways. So traditionally as a fraction, you can also write with the word 2 or with this colon in between A to B. So this is what a proportion is. It's just two fractions that are equal to each other, basically. And what we find out here, 6 divided by 18 is 1/3. But one thing that's always true about a proportion is if you cross multiply, you do 6 times 3, that's always going to equal 18 times 1. And if I set up another one, like let's say I just say 1/2 equals 4/8, this is true, right? So if I cross multiply, I get 8 times 1 equals 4 times 2. That's true as well. You can try it for any fraction, even like 6/9 equals 12/18. This is also a true statement to begin with. If I multiply 6 times 18, it should be equal to 9 times 12. And you can confirm that with the calculator if you want, or just take it like that. They're both equal to 108. Okay, so cross multiplying is going to be, maybe you've heard this before. This is what we mean by cross. Like you're making an X, basically, with the fraction. So example 1 of proportional reasoning. If let's say I give an assignment that has 12 questions, so I decide to make it worth 12 points. Seems reasonable. However, this assignment, I don't want to be worth so much. So I want to make it worth only 4 points in the actual grade book. But there's 12 questions, so it makes sense to give you, like on quizzes, maybe there's 12 questions, but I only want it to be worth 4. What do I do? Actually, the grade book can do this for me, but this is what the grade book is doing. Let's say some student scored 7 out of 12 on the original. What would his score out of 4 actually be? PowerSchool will calculate this for us and make it into a percentage, but what is it actually doing? So we take 7 out of 12 equals what out of 4? That's really what we want to know. So we set up a proportion, and then we cross multiply. 7 times 4 is 28, and x times 12 is 12x, and then we just divide by 12. So 28/12 is 2.3, and the 3's keep going, so I'm going to put a bar. That means they repeat. Okay, so your score is actually 2.3 out of 4, and what PowerSchool is going to do is round it to do decimal places, so that will just do 2.33/4, which is a little bit unfair, but that's kind of the best we can do. So next, another equation. This is where we're gonna the main skill I want you to get used to. If you see two fractions equal to each other, the easiest really thing to do is cross multiply. 3 times 20 equals 4 times x. So this is 60, and then divide both sides by 4, and that should be 15. Okay, another one. This time we've got a little bit more going on. If we have two terms up here, we should put secret parentheses because that will remind us. When I multiply, I put this in the front here, and that means I need to distribute. So I get 77 minus 7x. Common mistake is just to do 7 times 11 and forget about the x. So then on the other side, we have 4 times x, and now we have to solve this equation. So add 7x to both sides, because we want numbers on one side, x's on the other side. Divide by 11, and we get x equals 7. Okay, one more. Now we've got terms on the top, 2 terms on both numerators. So just be careful. Make sure you distribute both times. 5 times x minus 9, and then 4 times 8 plus x. And the idea is to get rid of the fractions. You shouldn't have fractions at this step. So then distribute 5x minus 45 distribute here. That's 32 plus 4x. And now get the x's on one side. Since 4x is less than 5x, I'm going to move it over here so that I just get x on this side and then plus 45 on the other side, and I get x equals 77. Okay, now what does this have to do with, once we start, the main topic is something called similar triangles. And so let's say we have this picture, David. Let's say David's right here. Actually, I think I have a picture of this. Yeah. David's 172 centimeters tall, so here's Dave. And he wants to find the height of this oak tree. So we'll call this H. Okay, he walks along the shadow of the tree until his head is in a position where the end of his shadow exactly overlaps the end of the tree's shadow. So then he's 344 this distance, 344 from the base of the tree. And we know 260 from the end of his shadows. So altogether, let's add that up. 260 plus 344 is 604. From here until here would be 604. So then we can use this little triangle. Okay, assume these are right angles. Compare it to the big triangle and set up a proportion. So the height of 172. Okay, this, if I make a ratio out of that height and the length from his foot to the end of that triangle, that should be proportional to the height of the tree, which I don't know, and then the entire base here, that's 604. So that's how you set up this. These ratios should be equal. The heights, put those both in the numerator, and then put the distances both in the denominator. And so the second one we just have to add. And now we can cross multiply. 604 times 172 should equal 260 times h. So let me calculate this. This is a very big number, 103,888. And then the last step is just divide by 20. So this tree is 5,194.4 centimeters tall. Probably makes more sense to think of that in meters. Okay, about 51.9 meters, roughly. Okay, that is it for this first section. Thanks for watching. Goodbye.